Excellencies, ladies and gentlemen, in Jakarta and in Japan, joining us online also, good morning. Welcome to the School of Strategic and Global Studies Focus Group Discussion and Technology Demonstration with a big theme of QUASI-ZENITH Satellite System Technology Demonstration for the Disaster Early Warning System. School of Strategic and Global Studies, Universitas Indonesia, in collaboration with Cabinet Office of Japan, present this event to all participants here live in Jakarta and remotely streaming in Japan. It's a platform and discourse among potential partners and stakeholders in early warning system technology development and applications in responding to disaster issues and challenges. My name is Taehyun On. It is a great honor for me to be the master of ceremony today. We are pleased to welcome the Excellencies. First, Dr. Arthur Subroto, the Director of School of Strategic and Global Studies in Universitas Indonesia. And please welcome Mr. Masato Nomiya, Director from Cabinet Office of Japan. Next, we present our honorable speakers. Professor Koji Suzuki from Kobe University, and Mr. Manabu Shimada from NTT Data Japan. Also, Mr. Naoki Izuzuka from Asia Air Survey. Lastly, Dr. Gary Potutan from Asian Disaster Reduction Center. And of course, we are proud to welcome our participants from multidiscipline backgrounds. Faculties of Universitas Indonesia, BRIN, BNPB, BIG, from BNKG, also from MAPIN, ASPI, PPS, PPBD DKI Jakarta, and lastly, BMPTST DKI Jakarta. Now we present National Anthem of Indonesia. Everyone, please rise from your seats. Audience, kindly be seated. Thank you. Now we invite the Director of School of Strategic and Global Studies, Universitas Indonesia, Dr. Arthur Subroto, to deliver his welcome remark. Papa Arthur, the stage is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Om Swastiastu, Namo Buddhaya, salam kebajikan. Salam sejahtera buat kita semua. A very good morning. Honorable speakers, Professor Koji Suzuki from Kobe University, Manabu Shimada, Entity Data Japan Corporation, Mr. Naoki Mitsusuka, Asia Air Survey, and Dr. Gary Potutan, ASEAN Disaster Reduction Center, and also distinguished respected participant from faculties of Universitas Indonesia, especially from School of Environmental Science, Faculty of Engineering, Faculty of Mathematics and Natural Science, Faculty of Computer Science, and TRRC Universitas Indonesia, and also BRIN, Indonesia National Research and Innovation Agency, BNPB, BIG, Geospatial Information Agency Indonesia, BMKG, Meteorological, Climatological, and Geophysical Agency, MapIn, from ASPI, PBS, Central Agency on Statistics of Indonesia, PPS, BPBD DKI Jakarta, enhancement of the disaster management capacity of National Agency for Disaster, special for Jakarta, Bapeda DKI Jakarta, penanaman modal dan pelayanan terpadu, satu pintu DKI Jakarta, investment and one-stop integrated service. Ladies and gentlemen, I would like to welcome you all to this FGD, QUASI-ZENITH satellite system, technology demonstration for the disaster early warning system. School of Strategic and Global Studies, Universitas Indonesia commits in leading Universitas Indonesia postgraduate program with multidisciplinary, interdisciplinary, and transdisciplinary approach that carries forward research innovation to enhance the vision and mission of Universitas Indonesia to be the world-class university. Technology and innovation is one of the academic and research approach in SSGS, School of Strategic Global Studies, Universitas Indonesia. Ranges of tools are explored, including satellite-based technology, such as the Global Navigation Satellite System, or GNSS. This year, SSGS Universitas Indonesia presents this focus group discussion and technology demonstration to introduce the QUASI-ZENITH satellite system, or QZSS, as one of significant technology for disaster early warning system. As big archipelago country with a big number of islands, around maybe 17,000 islands, Indonesia experiences hard times, facing various disasters and impacting a lot on social and environmental sectors. Therefore, SSGS Universitas Indonesia commits on academic and research discourse to find the best strategic solution. With this platform, we are also honored to be with distinguished participants today. We also expect to further possible collaboration with cross stakeholders to work on the possibility area in the future. To our dearly partner Cabinet Office of Japan and members institutions, our high appreciation for your sharing and technology demonstration today. Last but not least, to our School of Strategic and Global Studies staffs, students, faculties, thank you for your great work in hosting this focus group discussion. And lastly, with this, I officially open this focus group discussion. Please enjoy the event. Thank you. Very best morning. Wassalamualaikum warahmatullahi wabarakatuh. Om Santi Satya.
Thank you, Papa Arthur, for the warm remarks. Now, we kindly invite Mr. Masato Nomiya for his welcome speech, live from Japan. Please, sir, the floor is yours. マサトのみやさん、聞こえてますか？よろしくお願いします。Yes, yes, we can. Thank you, Mr. Masato Nomiya, for the great welcome speech. Next, we welcome Mr. Manabu Shimada, Manager of NTT Data Japan Corporation, to deliver a note from NTT Data. Yes, please.
Good morning, everyone. I'm Manabu Shimada, working at NTT Data Corporation. Firstly, I would like to thank you for this opportunity and especially University Indonesia for organizing today's event. It is a pleasure to have this collaboration. We have prepared our introduction with a demonstration that I hope you will like. Then we will have a discussion where I hope we can discuss our service and your needs. I hope that this will be a more than a single event. Instead, that we can continue to collaborate and benefit from each other's knowledge and experience. Thank you.
Thank you very much, Mr. Manabu, for the speech. Now, we move on to our main agenda, the focus group discussion and technology demonstration. For this session, all speakers will be invited for presentation and demonstration. For this, we kindly invite Dr. Lynn Yola to chair the session. Dr. Lynn Yola is a lecturer of School of Strategic and Global Studies, University, Indonesia. She has a strong academic and professional background in urban, energy, and technological innovation. Please welcome Dr. Lynn Yola.
Okay, thank you very much, Tayo, for the kind introductions. Very good morning. Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, thank you very much for being here with us today for our event, FGD and technology demonstrations of QZSS. And today, let me chair the FGD and the technology demonstrations as the moderator, of course, with the three speakers and one discussants. Today, we are going to have three sessions. The first one is the presentations that is going to be discussed with the three speakers. And after that, we are going to continue with the demonstration of the technology that we are going to divide into two places. The first one here in this seminar room for monitoring how is the signal going on. And the second one, the second group is going to the rooftop of the next building. The technology demonstration is going to be led by the speaker, and we are going to communicate from here indoor to outdoor and the other way around from outdoor, the rooftop, to participants here. So all of you might choose later which one you would like to stay. Is that watching the progress of the demonstrations through the screen and seeing how the signal is going on, or you will follow the speaker to the rooftop to see how demonstration of the technology itself. So later, yeah, we will ask you which one you will prefer. And of course, thank you very much to all participants that attend today. We kindly invited some faculties in UI and most of the government agencies that relates to this topic, QZSS, and as well as we have some private sectors. So we expect that this FGD is going to further or follow up to other step of the collaborations, of course, with us, Universitas Indonesia, and our dearly collaborator, Cabinet Office of Japan. And of course, Cabinet Office of Japan is going also to work with so many institutions in Japan. So hope today's event is going to give good contributions to all of your sectors, all of your institutions, as well as will further our collaborations in future. And for now, before that, let me invite all of the speakers and the discussions for today. Before their presentations, maybe we have small discussions here. The first one, let me introduce Professor Koji Suzuki. He is a professor from the Kobe University, Japan, and he is a project director of ASEAN Disaster Reduction Center. And he's also chairing steering committee of Sentinel Asia for 112 space agencies. The CV is very long, so let me just invite to the stage Professor Koji Suzuki, please. Please. And the second one, we have Dr. Gerald Potutan. He's a senior researcher at Asian Disaster Reduction Center, who also currently supports the projects of the QZSS DC report demonstrations, and also climate change impact projections and digital transformations in disaster risk reductions. Please, Dr. Gary. And last but not least, Dr. Naoki Mitsuzuka. He has worked using satellite remote sensing technique to analyze forests and other land use change historically. In recent years, he has been involved in international cooperations focused on analysis of using datasets of time series satellite data and high resolution image taken by drones. So please, Dr. Mitsuzuka. So they all arrived yesterday and directly did the trial of the demonstrations yesterday in the rooftop. So thank you very much for being here with us in Jakarta. And I invite our discussants, Dr. Iren Sonda. She is going to accompany me to discuss about the topics today. She is the lecturer in SSGS Universitas Indonesia. She is the spatial analysis specialist, and she's also working on disaster management system. Please, Dr. Iren. Yes. And of course, sorry. And of course, thank you very much our director, Bapak Ator, for always supporting our activities and of course the collaborations, internal, nationals, and internationals. And he's always here to be with us to work on the spatial analysis, technology development, and GNSS, as well as now we open the discussions on QZSS. Thank you very much, Bapak. And it's okay. Yeah, for now. Yeah, before we go to the presentation stage, I would like to ask some questions to the panel here. The first one is Prof. Suzuki. How is it the project so far? Because as we had just now that this promoting the QZSS utilization has been done in some countries in Asia. How is it so far, the progress?
Thank you very much for your question. As a member of the National Committee for this project and the Cabinet Office, I am monitoring or guiding this project for entire Asia region. And we selected 9 countries for demonstration and feasibility study. And out of 9, we have successfully implemented the first demonstration in Malaysia in August. And this country is the second, and working very closely with University Indonesia. And we have remaining 6 countries for demonstration. Those are Philippines, um, Nepal, Cambodia, and Mal no, Mal Mal I, the demonstration country was 7,
10 countries.
6. Those are Malaysia, Indonesia, Bangladesh, Philippines, Indonesia, and Cambodia.
All right.
And we have finished one of them, which is Malaysia, and we are now in
In Indonesia.
Yes. And we have another 3 countries for PhD study. Those are Fiji and Australia and Thailand. And this is the second case of demonstration. But I understand this is not only for demonstration. I think to make demonstration in this country, we have to have the expert who knows very well about this technology and try to, and we'd ask them to think about how you can implement, install this system into your country.
Yeah. Thank you very much. And we have some invited participants, a list of participants here, across interdisciplines and agencies in Indonesia. How is the response so far from your past demonstration in Malaysia? Was it good from the government agencies, like what we are doing here today? That yeah, thanks God, a lot of them coming. Dr. Gary.
Okay. The response, I think, would vary depending on the existing capacity and technologies and practices, as well as culture in a given area. And for example, in Malaysia, they have some existing technologies and early warning. They have existing technologies like, for example, in landslides and for floods. And if you have a new technology that is being introduced, such as the use of satellites, um, how you can integrate the system and whether it's a good redundant application and how it fits the community's practices and their culture are important things. These are some of the factors that are important. So the response of the community and the government is more likely that they would use it as redundant. If they don't have any, then it's one of the best options that might be available. So the same thing might be in Indonesia. We look at what are your existing systems and practices, and if fit well, then I think it would be a good system to integrate or as a system as a redundant for like in this case early warning.
Yeah. So it's potentially having good response then, from those stakeholders. Thank you very much. And Dr. Misuzuka, I think you are just so ready for these demonstrations. Yesterday you did the trial of the demonstrations and try to explain some topics to us yesterday. Was there any challenge in testing the signal in other country outside of Japan so far?
Selamat pagi. In the case of the Indonesia, for the characteristics of the QZSS system, this satellite is a very specific orbit, not for the whole of the entire Earth, only the Japan and also surrounding country, especially for the vertical line. So the Indonesia is a very good suitable situation for the orbit of the QZSS. So I think it will be good coordination and application for mitigate the disaster for the Indonesian people. We hope to be used. Thank you.
Yeah, great. Thank you very much. Some participants was already asking me, is it going well? Is it going working well in Java Island? Because the road of the satellite itself is, I think, very close to Kalimantan Island, instead of the southern part of Indonesia we see today, whether it's working well or not. Yeah, Dr. Iren, we have a lot of disasters in Indonesia, name it flood, earthquakes, and tsunami and everything. How ready are we to accept these invitations from Japan to implement the QZSS technology?
Okay, thank you, Ibu Lin. I think since this technology has some advance in like uh, connect with connect in a low signal that not in the same or conventional signal. So I think it's uh, potential for Indonesia since we have so many remote islands, so that less signal. Even in Java Island, I think if there's some like crisis things like disaster, for example, we still need not only for early warning system, but also with the evacuation phase and others. So in response to that things, we also realize that Indonesia has a specific condition since we are archipelago and also many remote island. I think this kind of technology should embed it in our technology adaptation and mitigation. I think.
So we are ready.
Yes, but I want to ask maybe all of you in here about are there any specific requirements that you choose 10 countries as your as countries to demonstrate this technology? Are there any specific requirement? I mean, why do you choose these 10 countries? Maybe you can explain.
To receive the QZSS signal safely, you need to have some sufficient elevation angle. And we check that each country, how much is elevation angles. So I found that Indonesia has a sufficient elevation angle to receive the signal from the satellite. That's why we selected Indonesia as one of the demonstration countries.
All right, thank you very much. And I think it's time for us to listen to what is QZSS and what it can do for us in Indonesia and to other countries in Asia. With that, I kindly invite Dr. Naoki Mitsuzuka to present some materials before we do the real demonstrations of the technology. And for questions, I hope you can hold it first until the discussion sessions, because we need to further the sessions to the demonstration after this. So after the demonstration, we can continue with the discussion itself. So please, Dr. Naoki Mitsuzuka, please.
Good morning, ladies and gentlemen. Thank you for participating in this meeting, and especially thanks to Director Dr. Ato and Dr. Lin. Thank you very much. Now I explain about the outline of the satellite report for disaster and crisis management. In this presentation, we call sometimes DC report. That means a disaster and crisis report. Using Michibiki satellite and sharing the experience of the demonstration of this service. Michibiki means in Japanese guidance. Guidance to avoid the danger. Agenda is like this, but I made very short and some skipped on the schedule. So first agenda is lessons learned from the Great Earth Japan earthquake in 2011. You know already, also there was a big earthquake in Japan. We learned many things from that tragedy. But and the second issue to be resolved and the project purpose and the superiority. This is a scenery after the big earthquake and the tsunami. Tsunami destroyed many cities like this. And this was happened March 11, 2011. From this disaster, what we learned is under this slide, we see the timeline. Happening of the event after 24 hours, 72 hours, and 1 week, we lost the termination of service. We could not connect to the telephone and the smartphone like that. And also, all this week, blackout, no electricity because of the destroyed of the social infrastructure. So what we learned from this tragedy, here on the left side, this is the situation now, also same. Broken of the facilities for, here? Oh, but can't. Okay, thank you. And with this kind of the this construction of the internet connection and Wi-Fi and any kind of the social infrastructure, this area which can provide information from the organization for the disaster mitigation, they know what happened, how to refuge. But the area which destroyed of the social infrastructure, they don't know what's happening, what they should do. This is the situation now. And after the QZSS system is go on working, from the station to the Michibiki satellite, QZSS system, sending the DC report and direct from the satellite. No need to the social infrastructure. So every place people can refuse from the disaster and casualties will be reduced. That is our essential aim, objectives. So Japanese positioning satellite is a Michibiki and the QZSS. That is a complement of the GPS system. This is the main objectives of the Michibiki. But also Michibiki QZSS has a function of satellite report for disaster and crisis management. It is called DC report. From the QZSS, we can directly receive the DC report to the smartphone and other facilities to make information by the loudspeaker or like that. So after the this construction of the destroyed of the social facilities, we can get the directly DC report. And the DC report is now under the process to expand its function, and it is planned to provide this service to abroad, to your country also, from fiscal year 2025. And the purpose of this project is to conduct technical demonstration for the expanded service of DC report to be provided in Japan and also other countries. this one. And the outline of the demonstration we already did. This figure is a summary of the already done demonstration in Thailand, Fiji, and Australia. And target disaster is different on each countries. Forest fire for Thailand, Fiji for tsunami, Australia for forest or bushfire. And the depending on the situation, target users is different, and also used device is different. In the case of Thailand, smartphone and loudspeaker. In Fiji, only loudspeaker, and in Australia, smartphone. In case of us today, very similar equipment with Australia. Almost only the set of smartphones. This is already we talked about the elevation angle, how high the satellite orbit. This is the center over here is the orbit of the Mitsubishi satellite. So in case of you, this red point in Jakarta, so the very suitable for receiving situation for the DC report, receiving DC report situation is very good for suitable for your country. And in case of Thailand, also walkie-talkie was used for the forest fire mitigation. And comparing with that, this system has visual map information on the smartphone. This is a merit of the QZSS DC report system. And Fiji, so our system will be applied to the characteristics of the each region. In the case of the Fiji, we used general QZSS system plus and the LPWA expanding the wireless communication system is aided. It was well suitable for the situation of Fiji. In Australia, we brought same system today. So after this presentation, you can touch with these equipment, this kind of smartphone and one more equipment with the GNSS antenna, high responsibility. And also this more small one with some electric small parts with smartphone together. We brought these two kinds of equipments for the demonstration. How will it work? He has smartphone which can receive the DC report. Sounding the smartphone.
There is no immediate danger. Stay up to date in case the situation changes. Calls to action. Stay informed.
And you can see again, also on the map. This is a sample image of the working of the QZSS system for DC report. And to the first point, what is the Michibiki satellite? This is the orbit of the Michibiki satellite, like number 8. This is a very specific objectives and the orbit QZSS have. And this area, inside of this area is suitable for the application of QZSS systems. Positioning service and pointing enhanced service, positioning enhanced service is the main objectives. And the last one, message service. We use this for this disaster mitigation. It's our objectives. And this kind of the message will be transferred to the each smartphone of the application. And the conceptual model, I have no time to. In the case of Indonesia, for example, or in the future plan, from the your capital or another place, authority for the disaster mitigation. Then just after the disaster happened, send the message to the Japan. From Japan to the Michibiki satellite, send the command to send the DC report. DC report sent from the satellite to the disaster occurred area to someone's individual smartphone, and also equipment, for example, the making loudspeaker, making to inform with the voice big in the each local area. Also, this works automatically. Nobody needs to stay here and talking. That is a very good point, I think. And this is creating a message system on computer. We set the area affected by disaster like this episode, and making DC report. Many ranking of the disaster severity, and also select the how to announce. You can make some parameters and send this one. So this DC report contents was sent to the Japan, and from Japan to the satellite, and to the each individual. No need to line for the social infrastructure. So that is from the Michibiki satellite to the local station, and also transmit from the local station to the individual or individual houses. So after this presentation, we will have the demonstration. Receiving with these equipment straight from the Michibiki satellite. We already set the DC report every 4 minutes or 5 minutes, already planned, and already Michibiki satellite sending the DC report also now. So let us show the smartphone receive and check how is the situation. And also I have the simulator like this on my PC, and we can see who are staying in this room, I show how to make the dish report and send. And the smartphone, how is responsible. And in the case of the Indonesia, these disasters are planned with the suggestion of Dr. Lim, and the heavy rainfall, volcanic eruption, and earthquake is aimed for disaster. And the summary, in the greatest Japan earthquake, we at that time ground communication network was damaged, and it was impossible to transfer information to disaster affected area and also to the individuals. So in Michibiki system, QZSS, there are satellite report for disaster and crisis management. This report as a message service. Michibiki satellite transmits crisis management information using the common format of EU Galileo. It is satellite network and less vulnerable to disaster. Demonstration and field tests were conducted in Thailand, Fiji, and Australia, and the demonstration showed Michibiki satellite is effective in outdoor and possible to receive early warning system and issue a warning to surroundings. Furthermore, it's possible to develop a system to distribute information widely by integrating LPWA, etc. This satellite and the system can be free of charge, and it is possible to transmit information regardless of damages of the disaster. Terima kasih.
Thank you. Thank you very much, Dr. Misuzuka. Yeah, maybe one cheating question from me. I know that they're already discussing back there, and there are a lot of questions coming. I saw that the message could be received in the form of message in Android, right, in your smartphone. Is it possible to receive the message or the warning message not through the smartphone? For example, you have the manual type like having the siren in those area that maybe some of them are not having the smartphone or internet, for example. Is that possible? Is it working?
Yes, we can prepare such kind of the hardware and automatically, not through the smartphone, for the specific hardware.
Yes, Dr. Gary. Is it possible to have like, the siren in the coverage area? Like the siren will alarm that disaster is coming. So even though if you are not having smartphone and receive the message, you will be alarmed that disaster is coming through the siren. Yeah, the loudspeaker. Yeah, yeah, it's possible. All right. And I saw just now you already did some trial in Gunung Semeru and Gunung Merapi. Was it going well? Gunung Semeru and Gunung Merapi, you tried, right, for that area? Not yet? Not yet. Oh, the data. All right. So hope you can try in those areas. Okay. Thank you very much. Maybe one cheating question from the audience. Is there any? Yes, please, sir.
Thank you very much. Good morning,
Morning.
everyone, Professor, Doctor, and all the distinguished guests. My name is Iqbal from Department of Geography, Faculty of Mathematics and Natural Science. Thank you, Dr. Mitsuzuka, for a kind of presentation. It's very insightful and interesting. And I have point to discuss. As you may know, in Indonesia, actually we have probably similar system or application, Android based as well, like Info BMKG, InnoRisk, and I think many more similar application. Maybe it will also interesting to hear from BNPB and BMKG as well, but I would like to know from your point, what's the position of your technology if we would like to apply this technology in our country, because here we have also similar types of application. For example, I just download the info BMKG. It will alert me if earthquake is coming or if earthquake happen in some area in Indonesia. So from your point, how you position this technology in our country? Is it going to be a different system or different technology, or is going to be infuse this technology to our system that we already have here in Indonesia? Thank you very much.
Thank you very much. So you got the questions. Is it going to be totally one separate new technology, or we can insert it in the current existing technology in our country? Please.
Timely, yesterday, there was a big earthquake around the East Island. So just the same time, I received the information for the tsunami warning, just same time. But I can get this information through the internet and Wi-Fi for the smartphone. How do you think when the station for the Wi-Fi and the smartphone is broken? I cannot get this information. But through the Michibiki, I can get. That is the position of the merit of QZSS system.
Yeah, thank you very much. And of course, for the formal settings, G2G collaborations would be needed. Yeah, of course, we can install in our smartphone, but G2G agreement will be needed also to make it more comprehensive and more specific to our needs. Yeah, thank you very much. I'm so sorry I have to limit the question to one only because the committee already alert me that the time is off. We need to start the demonstration very soon. But after the demonstrations, we will open discussion for everyone in this room. Sorry for that, but for now, let me invite our director, Bapak Ator, to give token of appreciations to the speakers, yeah, before the end of the event approaching. So please, I invite Prof. Suzuki, Dr. Gary, and Dr. Ms. Suzuka to be on stage to receive the token of appreciations from our university. Please, Prof. Suzuki from Kobe University, Japan. Thank you very much. Documentations. Yeah. And Dr. Misuzuka. Thank you very much, sir. And Dr. Gary. Thank you very much. Thank you. And maybe take some photo. Yeah. Come. And maybe with the participants, is it possible like this? So we get the participants in the documentations. Yeah. Nggak apa-apa. You can take everyone in the room. Ya, satu. Berdiri, please stand up. Cheers. Thank you, everyone. Thank you. Thank you very much, Bapak Ator, for the appreciation, token of appreciations. And ladies and gentlemen, for the next sessions, we will divide the participants into two groups. Yeah, the first one will be in this room to see monitoring the process of demonstrations and the signal coming out. And the second one will go to the rooftop. Our committee will guide you to move to the next building, to the rooftop. So which one choose to go to the rooftop? Can you please raise your hand? 1, 2, 3, 4, 5, 6, 7, 8. Okay. The committee will guide you all to go to the rooftop and the speakers will go there. And the rest will stay in this room with me and we see the signal coming. Yeah. After the demonstrations, we still returning to this room for the discussions. Yeah, for those who wants to go to rooftop, the committee will help you to move to the next building. We are going to do the demonstrations in the rooftop. Yeah. Ya. Makasih Bu Pak. ada tamu. Ya, ya, siap. Ada tamu Pak ya. Ya. Ya, makasih banyak. Terima kasih Pak. Benar. Orang lama. Ada Pak Iman nih dengan timnya, ada Zaim. Everyone will stay. Oh yeah, yeah. If you have any questions, Prof. Suzuki is here to answer you. Yeah. Dr. Gary, all good. Yeah. Mbak Ira.
The card. Okay, what I have. OG. Doctor. Green. Okay. Very excellent. Innovation leading leading agency for innovation in Indonesia.
Actually, I have.
Okay.
Okay. Maybe by microphone. Okay, Dr. Suzuki, I'm very happy to
welcome, and then we will start.
Hello, Taeyong. Yeah. Can you hear very clearly? Yes. All right. All good? Taeyong, Taeyong and Dr. Gary. Yeah, you are coming down? Okay, okay, good. Thank you.
Join with the QGIS to make disaster and crisis messages. For example, you have the smartphone of you. No, this one. If you have this smartphone and installed, now the name is the resident contact application. This center, green one, and working. Please give it. And when disaster occurred, center or organization of the disaster for disaster mitigation on this system. First, we set the area affected by disaster like this ellipsoid. And the next, we set this information message type. Now, this is a test message. So the country region is Indonesia. And also the hazard category and the hazard type is selectable like this. Sorry, this is just a emulation system, not real one. But this system will be launched in future truly. Thank you for participants in outside. Thank you very much.
Please welcome participants. You might have a seat, and please you can have some coffee break and some water at the back there. Water and tea or coffee you might enjoy, and snack box is already in your seat. you might enjoy while we are doing the discussions.
Thank you for information for keeping good health.
Yeah, I know
Dr.
it's
Lin.
very hot in the rooftop,
yeah,
so please take some times to cool down and enjoy the snacking and some drink.
Now on the screen, we show the system for making DC report, disaster and crisis information report. Set some parameters like this. Countries Indonesia, and the hazard category and type is selectable like this. And also here, guidance version and the guidance instruction library. We can select two level of the warning. These selector shows the announce contents. So for example, now I set this kind of the message and save. So now he has a smartphone with the this receiving system. Now from the disaster mitigation organization send to Japan the DC report. Successfully sent. Sounding like this. Show another guy.
So is it working? Bisa Pak? Bisa ya. Thank you.
So any other guy want to show the message receiving situation? You? Please show this smartphone. And I told already from the disaster hazard area sent to Japan. So this PC is in the simulation in that disaster area, and this cable connecting to the receiving system through USB, and from this equipment to the smartphone connecting with Bluetooth. So not so much for distance is not possible. So the person who receives the DC report must keep this one and also a smartphone. This is a now experimental situation. In future, only the smartphone or smartphone with very small equipment will be applied. So now sending report again. Successfully send it on the screen. Receiving the DC report. Okay. Also the maps we can see, and where you are is the figure of the man. Yeah, area is possible to make on the PC system. Not here only the receiving. Take on the PC we make Yeah, yeah. Because no need to other area, not to this.
Okay. Can we continue with the forum? Are you done? Oh yeah, yeah. Maybe we can discuss along with the discussions later. Yeah. Okay. Is everyone okay with the transitions from outdoor to indoor? I know it was so hot. Yeah, sorry for that. We wanted to choose evening, but evening I think is also hotter. So I think morning is better than the afternoon sessions. Uh, please enjoy a coffee break first. We have some water at the back there and coffee or tea and your snack box. And while we can do some discussions here, I invite again, please, Prof. Suzuki and Dr. Gary to be on stage and Dr. Iren. If you don't mind, we can continue the discussions. Committee, all good? Yeah? Okay. So, please. Please have a seat. Thank you. Yeah, Dr. Gary. Yeah, we were following what was going on in the rooftop. It was very interesting, though with the hot weather situations. Yeah, anything you want to comment on that? Because some of us couldn't get some of your statements or explanations in the rooftop. Is there anyone that you want to add on to that? What was going on, please?
Okay, so those who stayed here, what we did upstairs was we tried to look at the technology. This time we have a receiver, external one, that can transfer the message via Bluetooth to the smartphone. So that's one, and then there's a two more equipment that can directly receive because it's integrated in the smartphone. So we don't use the Bluetooth, and that's in terms of the equipment. And then in terms of the message, of course, we receive the message. All of the device receive the message, and they were able to touch it and see in text and also in audio.
The audio.
And also you can see your location in the map.
What is the form of the audio? Would be in the
Audio
smartphone. Is it like?
in English.
Is
So
it
like for example, if there is an imminent danger, you are at risk, then you
danger?
evacuate.
Danger?
Not
Is that
like
like that?
It's just a talk direct. It's a continuous talking. Yeah, yeah.
Ah, okay.
Yeah.
Dangerous. It's time for you to
To
evacuate.
Yeah,
Something
yeah,
like
yeah.
that.
It's time to
Okay.
evacuate. And
Not like the siren, like nging,
I know
nging,
it's
nging.
not like that.
No. Yes. Okay.
Yeah.
So it depends on
Depends
how
on
you program it, right? Okay. Okay.
So the program that we did up is only like text,
Text, audio, and
the map
the
location.
locations,
Yeah,
the
yeah.
coverage
Yeah.
locations. All right.
Of course, there were several questions, and then how the message is transmitted, and what are the mechanisms. And of course, there are some questions that we cannot answer. Maybe later on,
Yep. Of
it
course.
can be answered.
Of course. Before I pass the questions to others, is there any questions from the floor? Yeah. Yes, sir. Committee, please help us with the microphone, please. Mas Arik. No, no, that one. That microphone. Please.
Check.
Your name, institutions,
Yes.
and the questions, please.
Yes, thank you. My name is Ian. I'm from the National Agency for Research and Innovation of the Republic of Indonesia, or BRIN.
BRIN, yes.
Yes, and as we all know, every milliseconds is important in disaster scenario, right? We agree all on that. But in terms of performance, have you done the performance analysis or the comparison test on dispersing or distribution the warning message through the QZSS and compare it to the other channel as well? Thank
Ada
you.
satellite, you mean?
No, I mean like the other distribution method or channel in dispersing the warning message.
I
Thank you.
see. Yeah, I will take that question. Thank you very much.
Thank you.
Was there any comparison studies or experiment happened before? Please, the mic.
So there's
On.
performance already were done and it's with a company of Jisuka Sang. So there are 4 areas wherein the performance were evaluated. One is with regard to robustness. It means whether is this system can be affected if there are no Wi-Fi, ground, things like that, telephone lines. So in terms of robustness, of course, this one is very strong, high, because it's satellite based. So even if you don't have Wi-Fi, even if you don't have connections, you can still receive the message.
So without any fiber optics network in the area?
So that's one area. Another area is immediacy. It means can the message be received almost in real time?
Real time?
Or so like after 4 seconds, it's
4 seconds accuracy.
So almost
Okay.
real time that you can receive it, and there are no much distortion if there are long channels. Like for example, in the traditional early warning system, it can be sent from many channels, and there are some distortion, there are some delay. So your community. So in terms of immediacy, we call that immediacy is also high, and then we have the correctness of the information and the location. Like for example, because this one use positioning, so some of the messaging it will be sent even to the people that are not in the area at risk.
In the coverage area.
But this one is more accurate in terms of area affected. So you can send a message only to those people that are at high risk. Like for example, you have the WhatsApps, but WhatsApp it's distribute all the member even if they are not in the area.
Yeah.
So the correctness is a bit low for the WhatsApp, but for this one, it's the position is covered. So
More targeted.
yeah,
Right?
it's more targeted.
Yeah.
And of course, in terms of comprehensiveness, it's also high because some of the existing telecommunications do not cover areas that are very far in the islands or very mountainous areas. But this one, because it's the satellite, so in terms of comprehensiveness, even those without existing telecommunication systems can be covered.
Yeah, but
So that's the area of analysis that's being used in comparison to other systems.
so the fastest of the real time you said just now is 4 seconds. Is that the fastest? Every 2 seconds. You can please.
Once the message has been set and sent to the control station, the sent message will be disseminated through satellite every 4 seconds. But you need to have leading time to prepare the message.
Oh, I see.
The prepared message has to be sent to the control station in Japan. That is the leading time. But after that, every 4 seconds, the message can be disseminated.
Okay, okay. Thank you very much. Any response to that answer, sir? Please.
Oh, yes, thank you for the answers. And yeah, it's interesting. And 4 seconds is, I think it's a good time to dispersing the message through the affected area. But not the follow-up question, like, is there any like comparison, actual comparison between the system on dispersing the message through QZSS or and compared it to the another satellite distribution method, the message distribution method, like for example, if we use like the maybe can I
Starlink.
yeah, Starlink or maybe Iridium through the Iridium
Starlink, yeah.
satellites, how is it compared to those
Yeah. Was there any?
systems?
We have a very brief study to compare the capacity between QZSS and Starlink. And you have this document.
Yeah, yeah, it's
is
even
on
there.
the page, I don't know, the page. There is a page.
Yeah.
The table compare the capacity 45.
Page number 45. Yeah, so that's the comparison.
To use Starlink as a messenger, you need to have some big setup, and also you have to pay a big amount of money monthly. But for
to purchase, yeah.
Yes, subscription, kind of subscription. But if
Yeah.
you use QZSS, you don't have to pay anything for transmit that signal for this. And but the capacity, the speed of sending message, we don't have any study on that. I'm sorry.
Okay.
Yeah, thank you very much.
Thank you very much. I just want to hear from maybe BNPB or BMKG. Is the 4 seconds reading time just now is okay for the disaster time? Is there any from BNPB, BMKG here?
Okay.
Yeah.
Thank you. I'm Ihsan from BMPB. I think the
4 second.
4 second for dispersing or send message is it is good. What's we don't see in the demonstration, if there any method other than Bluetooth to the smartphone to receive the message. If I may, I want to hear the comparison with the FEMA EAS, Emergency Alert System, the American ones, which is it doesn't need
Bluetooth
device, LPWA.
Okay.
The phone will be receive the message automatically by the EAS American ones system. So what's the difference, or do you have a plan to build a system like that, or you will be depends on the LPWA, because Indonesia is a very big country.
Archipelago,
yes,
remote area.
I think the problem is not everyone will be connected the device or the smartphone to the LPWA. So I think we need other carrier or system to bring the message. Thank you.
Yes, LPWA is one of the methodology to disseminate the received message to the participant, to the individuals. But there is another solution. If one community has this receiver, and the receiver is connected to loudspeaker.
Loudspeaker, like
loudspeaker or signage.
Like sirens. Yeah.
Or sirens.
Yeah.
The entire community can be covered. The community people does not have to have a smartphone with them.
Yeah.
That is another way of application.
Yeah.
Can I?
Yes, please.
To respond to what the BNPB officers stated. So I understand this technology is how to send the message, the alert message from the sensor and until to the receiver. It not transmit to the end user like individual. So if we want to disseminate to the massive public, to the people, I think we need to find out our way. It depends in characteristic of the local people, of the village, for example, of cities area. So this technology, I think satellite based is until the receivers itself. So for example, these receivers, if this signal want to disseminate to public, to people, so we need to find out other other way, like loudspeaker, or maybe in Indonesia we have kentongan, like that. So that kind of disseminate the way to disseminate this information. Okay.
Yeah, so it's pretty much about the context, the area, the characteristic of people, and the available technology over there. Like the other one that we did in Minasa Utara, it was a very large water area and no coverage of signal over there. So we use GNSS technology without any signals from the phone and from the internet. So we managed to be connected to the satellite. So same as this one, but of course the characteristic is different. So it depends on that. And we also invite all of the institutions, if you have any idea, of course we can also collaborate to develop this technology. All right, another one, any more questions from the floor? Yes, sir. From MIPA again. It's from UI, from Natural Science Faculty.
Yes.
Please.
Hello again. I was at the rooftop and I've
Yeah.
seen the demonstration, and it's very. I have a lot
Hot.
of useful information. Thank you very much
Yeah.
for that. But I'd like to raise a point. Most of the discussion here is about dissemination of information.
The
right?
message. Yeah.
Yes, the message. How is the speed of information transfer?
Yeah.
But I think we also need to consider the accuracy of the information itself.
The accuracy.
Because yeah, I just saw when I entered the room, I just saw the screen showing the maps, and inside the map there's a polygon, circle polygon area,
Coverage area.
yeah, the coverage area, and maybe we can also consider how to how to map the extent of the danger, how accurate the map itself, because as we experience in our application here, just what I just mentioned, like Info BMKG or Inaris, everybody got the message.
Yep.
Whether they are inside the danger area or not. But one thing that the innovators raise in terms of the advantage of their technology is the people, only people are in the danger area that inform, right?
Alert.
Please correct me if I'm wrong.
Yeah.
But back to my question, how the accurate of the information is there coming from the spatial modeling that you just show in the QGIS, or any methodology, scientific methodological behind the modeling or spatial analysis? That's what I want to know as well.
Yeah.
Besides the how to disseminate information, I think.
Yeah.
That's my question. Thank you.
This issue happened in Jakarta, where we have some alert for flood early warning system, and during the flood itself, it didn't alert, but when the flood didn't happen, it alerts. So there was some faulty in the technology. So that's what he was trying to say. What about the accuracy? What about the message? Is it were you testing that and blah blah blah? Yes, please, sir.
That question is very, very important for the data management agencies, which will disseminate the early warning message.
Yeah.
But this is exactly the agenda to identify the risk identification, and the making the area by this QZSS system is slightly the different item. Identify the area is the work of the officer who sent the message, but risk identification, the area, is not the work of the message with the officer to send the message. So precisely identification of the area is another work to do.
So there is the monitoring station as well. So it's not like directly, I mean, the message is not directly sent, but there is another, what do you call that, step in the monitoring station that would also read before it sends to everyone. Of course, it should be real time, but yeah, this monitoring session should be always ready, yeah, to watch. All right, thank you very much. Any more questions? Yes, please. Yeah. They don't give you rest. Yeah,
Thank you
please.
very much for the opportunity. My name is Bagus Bakdirawan. I'm from National Research and Innovation Agency, as known as BRIN.
BRIN.
Dr. Lindiola, I believe we met before. And I have a question regarding is there any possibility to do two-way communication in the near future? Because we in BRIN, we have the chance to, in the few years back, we have the chance to develop a tsunami early warning system that placed on the middle of the ocean, so uh, there is no radio or there is no signal there. So we solely use iridium back there, iridium satellite to do the two-way communication. And is there a possibility that we can use QZSS in the future? Thank you very much.
The end user also can give some message back to the authority or these monitoring stations. Yes. Any?
That is the question I have been waiting for. Yes, in the case of Japan, we have two-way system. You can send a message from the national disaster agencies to the affected area. And we also can collect the situation from the affected area to the central government.
To collect the message from the users?
Yeah. So we can monitor what is going on the affected area. But currently the two-way system is not available in outside Japan.
Outside Japan.
But next week we have discussion with Cabinet Office if we can make two-way communication will be available or not. We'll have a discussion on that.
Yeah.
If it is available, this technology is a very big breakthrough of the challenges of loss communication matters of disaster management. Thank you for your question. I have been waiting for the question for long.
Yeah, and of course, need some collaboration agreement, G2G for this, and that's why we are inviting you all. If you have any idea, and of course they take notes and they report to the Cabinet Office of Japan that there is some concern on this. Any more questions? Oh, you want to add to that, please, sir?
No, it's not. I just want to raise the questions that I cannot answer. Yes, about the automatic sending of message.
There was
colleagues
delayed
can answer.
questions before. Yes, please.
Yeah. Thank you very much for your explanation. My name is Yedi from BMKG. Regarding the preparation of the MT4 formats, my question is, can we generate or create this format by ourselves instead of using plugins, or QGIS plugin, as you demonstrate before? Our concern is to reduce the time regarding the preparation of the warning or message format. So if possible, it can be generated automatically by the system or something like that. I think we can reduce the preparation time. As you mentioned that 4 seconds is counting from the data already and then sent to the satellite and then to
the
receiver.
monitoring.
This 4 seconds, outside the preparation. That's our concern. Thank you.
Yeah. Please, Dr. Gary? Oh, you couldn't respond. Anyone? That Prof. Suzuki and Suzuka?
If we can connect the risk monitoring system to QZSS system, the message can be automatically generated and send the message to the control station. So it depends on how to configure, set up the system. We have to combine two systems in one, risk monitoring and MT44 message creation. Two systems have to be combined, can be combined.
So integrated one. Yes, not only standalone system. Does it answer, sir? Yeah, maybe you can continue discussions later after this if you want further details, explanations. Yeah, any more questions? Yeah, Dr. Iran.
I think I make some before. Yeah, yesterday I made after I saw your presentation. I think I made some.
You make some
like response.
Yeah, in notes.
So in notes maybe.
Mas Pras, please present.
So I want to divide it into 4 parts. First, about the institutional aspect of the technology users. So this Michibiki DC report extend its service beyond Japan, right? So yeah, like you said, 10 countries with control stations situated in Japan. So my question is to what extent can Indonesia as a beneficiary country access the information, I mean, or data from this system to support the development of its own early warning system? Because I think this kind of data or information, I think, is also useful for us to make like risk reduction scenario or other kind of planning of disaster issues. And maybe I will ask for several questions. Some of question I think already answered by yours. And about this technology, could this Michibiki DC report collaborate with the existing early warning system in Indonesia? I think someone who already asked, but I want to ask about how to elaborate more than one source of disaster warning alert. For example, in Indonesia, in Jakarta, we are not only depends on the formal institution like, for example, BMKG or BPBD to know about, for example, flood. We also have some like, we know the user of social media, for example, like Twitter or something like that, are in a massive number in Indonesia. So there are some I think some institution has collect the crowdsourcing data to prevent people regards the flood. So I mean, this kind of source of information, I think it's a good one also. So how this technology can combine many source of data? Could this technology manage many type of source of data, something like that? And I think the others already answered by your side. So there are 2 questions in general. First, in Indonesia, how can, if Indonesia as a beneficiary country, how can we access the data since the disaster data, like the information that received in your command center and send back to Indonesia, to the user in Indonesia, right? So how can we how manage that data, that information? And then second is this technology or also can elaborate more than one source of disaster
message
alert? Yeah, message.
Yes, please.
I have not yet get the point of your first question. And would you elaborate again
The first one.
Yeah.
Since the like the warning alert
Yes.
sent from Indonesia, right? And sent to the command center in Japan. And then can we access that kind of information or data?
Yes, you can monitor your send message is how the send message is processed. And once the message is disseminated from the satellite, you can monitor that timing on the screen. So you can follow up once you send the message to the control station, where it is, and the message has been already disseminated, and those process has been monitored by yourself.
Okay.
Yeah, so it should be
satisfied you?
authorized one.
Yeah.
Authorized.
And if not disseminated, the alert message has to be bounced back.
Yeah. And I think it needs some kind of like control access from Japan as well.
Control what? Do you mean?
The access, the permissions from Japan to do that. But I think if we do some collaborations, that should be agreed.
Oh yes, agreement.
Yeah.
Yes.
Yeah. So we need G2G.
Yeah.
G2G, yes, there is some
agreement.
TOR or treaty
Yeah.
sometimes we have set up.
Yeah. That's why we invite many friends from
Yeah.
government institutional that we can follow up then.
Yeah, you can work together to respond to these demonstrations. Yeah.
Yes. So regards the more than one source of alert
Yes.
information.
Please take this technology and the free satellite communication tool, just a tool. You try to apply a lot of resources to risk alert. So once the risk alert is integrated from a lot of resources and set up alert message, you can disseminate it. The message system and risk identification system is a different one. The question is we have the same similar question from
integrated one.
Just integrate.
Yeah.
Those two systems have to be integrated.
So we need someone that integrate that kind of information, then send to the satellite.
Yes.
Okay. So it needs still some process.
The stations, the monitoring stations. Yeah.
But we are willing to make some contribution to integrate.
Okay.
Yeah.
Okay.
Thank you.
Thank you.
Thank you, Dr. Iren. Is there more questions or response or comments to today's demonstrations? Bapak Darmawan, Bu Fatwa, ada komen? No? Any more from the floor? I think there are some students attending this event today. Any questions? Yes, sir. Dari BMKG.
Just to emphasize what Bu
Iren.
Bu Iren asked about the elaborate the data source format. So my question is there any possibility to another format? It's not depend on MT4 format. Is that possible, or we should convert the warning message into MT4 format?
Yeah. Is it directly, or it needs the conversions?
As far as I understand, currently only MT44 message can be applied to QZSS RD1 system. But you can develop the RD1 message by pull down menu. You don't have to, you yourself have to write the message into MT44 message. You can create your message by putting down from the tables.
Yeah.
It is very easy to make the message.
Convert, yeah?
Convert. Yes, the system automatically convert your message into MT44.
And is it automatically?
Automatically. There is the application,
it's already
the system. He showed it on the screen. QGIS system. You can select you can select from the table what is the disaster, when it's coming, just selecting from the pull down menu. The system itself automatically convert your message into MT44.
Okay. Any response to that answer? Okay, thank you. Before I go to the collaborations discussions, is there anything you want to show again, Doctor Misuzuka? Because I interrupted you just now showing from your system. Yeah, is there anyone that you want to show?
No, nothing, anything that, but I think maybe better to, if somebody want to just come and touch the system for making MT44.
Okay, thank you. And yeah, this is the very important one. We cannot stop here. What we expect inviting all of you to attend this FGD is actually what's next. Yeah, and those gentlemen here, they are ready to further the communications after this for collaborations. And I think we have a pretty much related institutions here that could be possible to work with us, with them, yeah, in this area. And anyone want to highlight any concern on the collaborations? And of course, after this, we open the communications through email and for the further communications for collaborations among our institutions. Anyone want to discuss about the collaborations? Any concern? And I think some of you are delegations from your institutions. Your boss sent you here, and of course we expect you to deliver this message to your institutions and discuss among your colleagues and your supervisors that we have this topic here and we are waiting for the next step for collaborations. Yes. You want to say? Yes, please, please.
Thank you, everybody, today's session. And you have the document on each chair, and inside of them, here is a anchor sheet questionnaire, and please write your name and your opinion, your impression. It's a very good help for us to progress this project. So please write. If not possible, all of them, only the part is also okay. Hopefully, please write every question.
Yeah, yeah. There is a question in your folder, and there are a lot of questions here. And you please might fill up those. Maybe you can tick, and you can add on some additional comments if possible. And if you have any message that you want to deliver to KAO, Cabinet Office of Japan, KAO is like kantor Perdana Menteri setnek-nya lah ya kalau kita. Jadi so they are the one that could connect with other ministries and departments in Japan. So please, if you have any message to them to be delivered to KAO, Cabinet Office of Japan, please do write so in the questionnaire and don't take the questionnaire home. You need to submit it to committee. It's either in this table or the table outside. Thank you very much. Any more questions? Comment? No? Pak Khotib? Yes? Yes, please. What questions?
Well, it's not a question, but you asked about future collaboration. So,
yes.
as Dr. Iran has been put out in her last comment about the local knowledge of people, or the way they have a specific kind of disseminating information in the local communities. I think the inventors perhaps would like also to consider the way local community spread the information, like kentongan, as
Yeah.
just Dr. Ren mentioned. And as geographer, we have human geographer expertise as well as in our department who also would like and interest in that kind of areas. So the local knowledge, local wisdom, maybe our expertise in our department can give some insight to improve or to to make the technology suitable for our local community.
Yeah.
Because our local community is one of the vulnerable aspect of the disaster. I think that's my comment. Thank you very much, Dr.
Yeah, thank you very much. Of course, it's very important, the social aspect, to make the technology better, because technology is technology. It can process data, blah, 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 but the local context, local wisdom is very important for us to adapt to those issues, potentials, and so on and so far. And please, you can exchange cards to further communications through the email letter. And of course, we in SSGS UI, we are ready to welcome you all to provide a platform for these discussions. And of course, we have very close relationship and collaboration with KAO. So anytime we are ready to have discussion on collaborations. Thank you very much. Any more concern from the floor? Any more comments or last message? No? Everyone is tired already. Okay. With that, thank you very much all of the speakers. Thank you very much discussants. And of course, thank you very much for the participants. Yeah, all of you here, wonderful. We didn't expect to attend this much. Yeah, I think it's more than what we expect, around more than 30. Thank you very much, and please continue these discussions or collaborations in the future. And thank you very much for the committee for conducting the event today. And yeah, before the lunchtime, maybe the MC will close later. But that's it from me. Thank you very much. Thank you. Very good. Almost noon. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Dr. Lin Yola, for chairing the session greatly. Ladies and gentlemen, our program today is closing to the edge. Thank you for being with us. To everyone that joins us today, we highly hope that this event gives positive insight and significant contributions. We also hope the discussion today also could be led to future collaboration. We will have another 2 days event on early of November on high accuracy Madoka Global Navigation Satellite System. We kindly invite you all to join us again next month. Please enjoy the lunch provided by the committee. And on behalf of the committee, we would like to extend gratitude for your kind participation and supports. Thank you and see you soon.
Can we have group photo before the lunch time? Please. Maybe over here, JJ. On stage, please. Please, boleh foto di stage ya, Bapak Ibu. Silakan. Ini nggak apa-apa. Muat ya. Di stage, muat nggak? Ah ya, ayo. Ayo Bapak Ibu. Silahkan. Silakan di stage. Ya, silakan Bapak Ibu. Ayo. Ayo, silakan. Muat nggak sampai di sini? Ah, di tengah. Aduh, saya diminta di tengah nih. They ask me to stand in the middle. Oke. Thank you very much, everyone. Thank you very much. Yeah, thank you. So, thank you. Please, there is a lunch box in the corner of the room. Ya, ada lunchnya, Bapak Ibu, silahkan. Dan snacking juga ada itu tadi. BMKG dari